Hello everyone, we are the students of Vignan, Department of ECE. As a part of the SH 2025, we have taken the problem statement as Student Innovation on the theme Robotics and Drone and chosen our title as Morphobot. A morphobot is a type of multimodal robot capable of changing its physical shape to adapt the different environments and perform multiple functions. The name combines the morphing and the robot. These robots are inspired by the animals that use appendages in versatile ways, such as birds that can fly and also walk or run on a steep inclined way. The device has the capability to turn its wheels into propellers and fly like a drone, and also turn the wheels back to the ground travel mode. Aerially transforming Morphobot. This version of Morphobot focuses on the mid-air transformation to transform smoothly between the flight and ground travel modes. This allows it to adapt the rough terrain that would be difficult to traverse during a traditional landing. This enables the entire swarm to perform a complex task collaboratively. Due to their versatility, morphobots can be used for tasks in complex and unpredictable environments. Search and rescue, navigating varied terrains, flying over the obstacles, and entering into the tight spaces in the disaster zone will be significantly increase the chances of rescue operations, and the autonomous delivery switching from ground to air transport gives us the best and efficient way in delivering the medical supplies. It can also be used in the search and rescue operations where the humans are inaccessible, and also in the hill trekking areas of high altitude for the supply of oxygen and essential food supplies. And finally, in the disaster areas where the infrastructure is being severely damaged.
Here the flowchart of the Morphobot flow control is given. Here it's connected to the memory control unit and the power supply to their respective.
Now coming to the flow of control of the device. The device mainly relies on the memory control unit. It consists of two parts, Raspberry Pi and the ESP32. The Raspberry Pi handles the major actions like the drone and water movements and also the servo movement. The ESP32 handles the sensors and the power management efficiently. Then comes the camera module. We use the high definition NATB camera for transmitting the visual information which is crucial for real-time response during the rescue operations. Next, the ESC, the electronic speed regulator or controller, which is used to power the BLDC and give the PWM signals from the receiver to the BLDC motors for giving the thrust regulation properly, for lifting the drone in a good and proper way. And we use the sensor MPU 6050 for the stabilization of the drone. It consists of 3-axis AID transcription for maintaining the stabilization of the drone, and we use the voltage regulator for converting the 12V supply to 6V supply for both the servos and the MPU 6050. The servos get the 6V supply and convert the action from 0 to 90 degrees for converting from the ground movement to aerial movement. Coming to the ground mobility, we use the driver module in the connection with N20 gear motors. The N20 gear motors have 3-pin gear structure which are capable of transforming low power into high torque. So these are very feasible for ground mobility. Now at last, the FlySky transmitter and receiver comes into action with a range of 1.5 kilometers when connected to the memory control unit for giving the PWM signals in a very pinpoint way. Now coming to the prototype, with the two circuits for different locomotion are being connected, and the arm and the body are also being designed. So as of now, 70% of the working model is been completed, and we are left with the assembly. Lastly, the Morphobot has the diverse uses and more applications, likely to be used in the defense sector and mainly to be used in transporting supplies for medical emergencies. Thank you.